大家好，我的名字是高一达，我很高兴在这里。这个演示我是用英文讲吧。Hello everybody, my name is Ida Gao, and I'm one of the co-founders of D-Route. D-Route is a layer 0 scaling solution. It's a network backbone, and essentially what we are building in the business of is essentially helping blockchain companies and anybody who's in the blockchain ecosystem move packets as efficiently and as optimally as possible from point A to point N. And how we came up with this idea and why we decided to incubate and co-found this company is that back in 2017, when we were investing in blockchain companies, we realized that a lot of the people in the space were thinking about how to solve scalability by coming up with next generation protocols, base layer protocols, or layer 2 scaling solutions. But nobody was really looking at what we considered a more fundamental bottleneck, which is the layer 0, or the internet on top of which all of these blockchains and higher layer applications are running. So that's what we set out to build D-Route. An analogy that I like to use is that if you have a Ferrari, which is your next generation base layer protocol, and it's running over a highway which is full of speed bumps, potholes, and red lights, then you can't really actualize the maximum speed of that Ferrari or that layer 1 blockchain. So we set out to build a autobahn, or information highway, if you will, for the blockchain ecosystem. So in Web 3.0, there's interactions with data in 3 main infrastructure buckets: networking, storage, and compute. For us, we're squarely in the networking bucket. We can actually work with a lot of the other networking companies in the blockchain space because we are essentially a next generation telco or ISP. So think about AT&T or China Telecom, but designed for the blockchain ecosystem. So we are very fundamental to the entire blockchain ecosystem and can work with virtually any of the companies that are building on top. So our friend Vitalik also agrees with us that there needs to be innovation in the networking layer in order for blockchains, including Ethereum, to improve in efficiency. So what are the current existing solutions today, and why do they not work for blockchains? Well, the internet, for example, is best effort routing, which means that it's plagued with packet loss at times where you don't want it to happen, with also high latency, and there's no sort of guarantees around the performance of the internet. CDNs also are not very compliant with live blockchain data. It's mainly used for cache content, and it's also not very good and optimized for bidirectional type of communication. They can also be very expensive to use. Private networks, again, are not great because they're very expensive, not decentralized, and really optimized for point-to-point connectivity, which is not what we see in the decentralized space that we all play in, where there's multiple end-to-end types of connections and communication amongst different types of nodes. So this is where D-Route comes in. Essentially, our team has solved a multi-decade, around 40-year-old math problem, computer science problem related to packet switch networks, any type of network really. We discovered a set of differential equations at Cornell about 5 years ago that essentially allows us to characterize any type of packet switch network. And we've optimized those differential equations and algorithms and commercialized them into D-Route, which is essentially a global distributed autonomous network. And as I mentioned, a good way to think about it is a next generation telco that has all the properties that you need in the decentralized world, but all the performance characteristics of a global telco. And we've won a lot of awards from the National Science Foundation to AT&T's Network Design Challenge. We were able to optimize AT&T's very complex network in about 30 seconds, whereas the second place winner had to do it in over several hours. And so what really is the D-Route network? It consists of a couple of layers. So the first underlying layer is our telco partners, or ISP partners. We have about 100 of those telco partners that provides the underlay piping for the transmission of the data, blockchain data in this case. And we use those Cornell routing algorithms that we discovered in order to create the sensing network and glue all of these pipes together in order to create this distributed SLA, high service level agreement network that we call DRoute. And relative to the internet, for example, we've shown significant improvements as it relates to latency, jitter, variation in latency, packet loss, and the like. So having done extensive testing compared to the internet, we have shown that in certain regions, we can actually be up to 99% improved over regular internet as it relates to latency variation. We have virtually zero packet loss on our network and never more than 1%. And high latency and high packet loss are very bad for distributed ecosystems and can lead to very poor performance on the blockchain network, and actually can decrease the TPS to virtually zero. So I think for us, we believe that DRoute solution is great for all of the blockchains that have very latency sensitive information and transactions that they want to pass through the network. So our go-to-market, who are we targeting? So we can go after permissioned blockchains, private blockchains, also public blockchains, POS and POW, decentralized applications and anything in between. And further down the line, we will also be able to provide analytics to folks that want to analyze blockchains at the most critical times because we are kind of in the middle of all of the information and transaction pass-through for different types of blockchain ecosystems. So thinking about who are the exact partners and users of DRoute, well, any entity that has sensitive data, latency sensitive data that they want to pass over the internet, they can actually use DRoute's core network, global network. So this is just an example of some of the companies and entities and projects that we can work with all across the infrastructure stack. So going from miners all the way down to decentralized applications, anytime you have sensitive data that's sensitive to latency, we can help with. And we've talked to a couple of these guys already, and they're super interested in testing with us and onboarding with us because of the stability that we can offer to them. So now talking about testing, we like to show some of the results and also some of the overview and observations that we've made. We've done extensive testing with not only private blockchains, but also public blockchains. On the private side, we've worked with one of the world's largest fintech companies out there. And on the POS side, we worked with BOS, which is an offshoot of EOS, controls a large portion of the block producers on the EOS chain. And then for proof of work, we've worked with some of the top mining groups in the world, focused on Ethereum initially. And some key takeaways is that as more information and data is passed through all of these blockchain networks, there's an accumulation of traffic that can lead to congestion and bottleneck at the infrastructure and at the networking layer, which if you don't solve correctly, can really decrease the performance of any type of blockchain that you want to build on. Number two is that for block finality and POS types of blockchains, it's really dependent on the time of finality is really dependent on the performance and stability of the underlying network. And number three is that if we can optimize on the networking layer, we can help blockchains be more efficient. For example, helping mining pools better utilize their hash power to direct to the next block. So I'll dive a little bit deeper. So PBFT, a lot of enterprise use cases for blockchain are using some sort of PBFT consensus algorithm, and for the fintech company that we've been testing with, what they want to build is essentially a global payments network using blockchain technology, a PBFT type of consensus, but they don't have a global network. And so we're the perfect partner for them to support their global payments network using our global distributed autonomous network. And we believe that more and more enterprises are going to come out with PBFT consensus type of blockchains for payments, for other different types of use cases that have similar characteristics as a fintech company we're working with. Many nodes in the network, node operators that may be in different cloud service providers, and also ones that have different varying needs and bandwidth. So DRoute actually has the ability to connect directly to all of the cloud service providers today, and that means that we can service all of these different types of network topologies. And just a primer on PBFT consensus mechanism, how that works, and why DRoute is very important to these types of blockchains is that when you think about PBFT, finality happens in multiple phases. From your request to your approval, commit, etc. Each of these phases takes up a lot of message passing from all of the nodes in a PBFT network. And all of these blockchains want to be as decentralized as possible, so they're going to add more and more node operators. And when you do that, the number of messages that need to be passed through the network increases exponentially. So you can see a main bottleneck would be on the networking layer, which leads to major congestion, and that can actually slow down the network to a standstill. And through the testing that we've done, we've seen that even with just one link failure in a PBFT consensus topology, you can have significant degradation and poor performance for any type of PBFT consensus chain. So what is needed for these types of blockchains? Well, you need to have a flexible enough bandwidth, so able to scale up and down the bandwidth capacity. That's relevant for whatever PBFT consensus you have. They all have different bandwidth needs. For example, Libra is about 100 Mbps. Latent is 25 Gbps. The second thing is you need to have a network that's global and also has a lot of stability. So guarantees around latency variation, jitter, packet loss, especially for very sensitive, time-sensitive use cases like payments. You don't want to have the TPS drop from X to X divided by 10. So you need to have a very stable network. And number 3 is density, and having a dense enough network that's global enough to support all of these enterprise use cases where you're not bottlenecked at the mercy of certain links failing. You want to make sure you have a dense enough network. And with our telco partners, we have that. Moving on to proof of work. So we've done also testing with several POW chains. I'll talk about Ethereum, given that it's one of the larger ones out today, and worked with some of the largest mining groups in the world and have shown significant improvements in reducing time to receiving a block by at least now up to 2 seconds. We're going to push that even more. But what does that mean? That means that we can essentially decrease the time that mining pools receive blocks so they can redirect their hash power faster to the next block. So that makes their hash power more efficient. And we can also decrease the uncle rates that these mining pools have, because we can propagate the blocks faster so they don't have to lose out on block rewards to another miner. So all of this means that at the end of the day, mining pools are becoming more efficient and can generate more revenue. On the top right is showing you just a small use case of 2 links between Frankfurt and Hong Kong, and the orange shows that with DRoute we can significantly improve the block delay times that these mining pools are hearing about blocks from across the world. We've also tested across multiple mining pools and have shown improvements in uncle rates for all of them. There's another observation that we've made, which is the transaction volume for a lot of these blockchains are still very, very limited. We believe that for the next 10x improvement in transaction volume, it's going to come from enterprise use cases and coming from permission chains. And enterprises, if you think about them, they will still require the same type of network performance that they were used to in the non-blockchain world. So what does that mean for dRoute? It means that we're probably one of the only companies in the space that can cater to their needs when it comes to flexibility. What I mean by that is being able to scale up and down the bandwidth needs for different type of enterprise blockchain use cases. Stability, which means that because of our high SLAs, service level agreements that we can provide around latency variation, and jitter and packet loss, we can provide the stability that they need in order to function for their highly performant use cases like payments. And density, which means that given our telco partners, we have a dense enough network that's global enough to support global enterprises. And number 4 is ultra-low latency. So this is coming from the Cornell algorithms that we've discovered over 5 years ago, and using those to essentially allow for the mathematically lowest latency possible for any type of enterprise blockchain use case. So we do have an enterprise-grade solution. We'd love to talk to anybody who is working on these types of blockchains. And for enterprises, we offer them SLAs around network performance and also network visibility and management, which is really important to enterprises because if something goes wrong, they want to be able to look into the network and see what the issues are. So now I'll play a quick video that helps you guys visualize what dRoute can do. The example video is for a video streaming use case. And this is, can be extrapolated for all the other use cases that I mentioned today. So if you want to play the video.
This demonstration shows the improvements by running the dRoute Global Autonomous Solution instead of over the open internet. First, we see what happens to traditional OSPF routed video traffic when loads are increased on the network. What you see right now is video playing in Singapore being viewed in San Francisco. This video is going to San Francisco via the shortest path, which is through Hong Kong. When we overload the network with 60 Mbps on 50 Mbps links with no way to dynamically reroute the load, the video quality suffers.
So this would be, for miners, propagation of blocks that are not fast enough.
Next, we'll spin up the dRoute network solution. Note, this process only takes a few seconds. Now the dRoute network is fully enabled, and we are running the same video and same traffic load on 60 Mbps. With the dRoute network, the video is virtually unaffected by traffic loads, which would saturate traditional links, as shown earlier. Instead, dRoute dynamically reroutes traffic in milliseconds to ensure perfect connectivity for blockchain-sensitive traffic routing, clearly demonstrating and seen by video streaming as this video streams perfectly. See how this traffic flows over multiple links, not just the shortest path. This ensures that the network observes the load even if the link is cut. As you can see here, the video plays on. dRoute's autonomous control system ensures mathematically optimal solutions for traffic routing, optimizing every 150 milliseconds. By using the dRoute network, blockchains can run on the highest network performance possible. dRoute's...
Okay. So that gives you an example for video streaming, but you can take that and you can imagine having this highly performant network for many different types of use cases, from payments to miners to anything in between. And as traffic volumes and transaction volumes increase, the need for a more reliable network is just going to also go up exponentially. So in Web 2.0, what we've seen is that a lot of the network backbones are very segmented, from your cloud service providers to your telcos to edge networks like IoT. They're not very connected. But for Web 3.0, what you do need is a more mesh type of network to interact with all of the disparate types of nodes that exist in the blockchain ecosystems. And the way that we're building it is essentially having the telco partners as our moat, as our differentiator. We developed those over several years. And on top of that, we overlay it with our routing algorithms developed from Cornell and also cloud service providers and others in order to create this global autonomous mesh network. And so to end, what DROUT really is we're trying to build a network backbone, a layer 0 network backbone for the decentralized world, and helping any type of blockchain and decentralized applications and everything between operate and perform at their highest potential. Thank you for your time. Got 5 seconds left.